Welcome to Mind Tier Learning, where we make GCSE learning and revision simple. We'll explore how gradients help us identify parallel lines, and we'll also look closely at horizontal and vertical lines. These lines are important because they appear in coordinate geometry, straight line graphs, rectangles, transformations, and many GCSE problem-solving questions. Before we begin, remember to like this video, subscribe to Mind Tier Learning, and follow along carefully. By the end of this session, you should be able to identify parallel lines by comparing their gradients. You will also be able to draw and recognize horizontal and vertical lines. Finally, you will learn how to determine the equation of a line that is parallel to a given line and passes through a specific point. The key idea today is that parallel lines travel in the same direction, and in algebra, that means they have the same gradient. Let's begin with the key vocabulary. Parallel lines are lines that stay the same distance apart and never meet. They share the same gradient. A horizontal line runs from left to right and is parallel to the x-axis. Its equation has the form y equals a. A vertical line runs up and down and is parallel to the y-axis. Its equation has the form x equals b. These special forms are very useful because they help us recognize lines quickly without needing a full table of values. Before we go further, let's recall the standard form of a straight line equation, y equals mx plus c. The letter m represents the gradient, which tells us the steepness of the line. The letter c represents the y-intercept, which tells us where the line crosses the y-axis. The key point for today is this: if two lines have the same m value, they have the same gradient. That means they are travelling in the exact same direction, so they will stay the same distance apart and never meet. Let's do a quick recall quiz. Question 1. What is the gradient of the line y equals negative 3x plus 5? Question 2. Where does the line y equals 4, x minus 2 cross the y-axis? Question 3. If a line has a gradient of 0, what does it look like? Pause the video and try all three before checking the answers. Let's check the answers. For question 1, the gradient is negative 3. This is the number multiplying x. For question 2, the line crosses the y-axis at negative 2, or the coordinate 0, negative 2. For question 3, a line with a gradient of 0 is flat or horizontal. That means it does not rise or fall as it moves from left to right. Now, let's look at the secret of parallel lines. Two lines are parallel if and only if they have the same gradient. For example, look at these two lines, y equals 3x plus 4 and y equals 3x minus 10. Both lines have a gradient of 3. Their y-intercepts are different, so they cross the y-axis in different places, but they rise at the same rate. Because they have the same gradient, they will never meet, no matter how far they are extended. Let's check whether we can spot parallel lines. Which of these lines is parallel to y equals 0.5 x plus 3? The options are y equals 2x plus 3, y equals negative 0.5 x plus 1, y equals 1/2 x minus 5, y equals 5x plus 0.5. Pause the video and think carefully. To find a parallel line, we need the same gradient. The correct answer is y equals 1/2 x minus 5. The original line is y equals 0.5 x plus 3. The gradient is 0.5, which is the same as 1/2. So any line with a gradient of 0.5 or 1/2 will be parallel to it. The y-intercept can be different. It does not need to be the same. If the gradient is the same, the lines are parallel. Now let's look at horizontal lines. A horizontal line is perfectly flat. That means its gradient is 0. If the gradient is 0, the mx part of y equals mx plus c disappears because 0 times x is 0. So, we are left with a line in the form y equals a. For example, y equals 4 is a horizontal line. Every point on this line has a y-coordinate of 4. The x-coordinate can change, but the y-coordinate stays fixed. So the points could be 0, 4, 2, 4, or -5, 4. The line is parallel to the x-axis. Vertical lines are different. A vertical line runs up and down and is parallel to the y-axis. Its equation has the form x equals b. For example, x equals -3 is a vertical line. Every point on this line has an x-coordinate of -3. The y-coordinate can change, but the x-coordinate stays fixed. So the points could be -3, 0, -3, 2, or -3, -5. Vertical lines do not have a normal gradient. Their gradient is undefined because there is no run across the x-axis. Let's check your understanding. A horizontal line has the equation form blank equals a. A vertical line is parallel to the blank axis. The line y equals 7 is parallel to the blank axis. Use the word bank to complete the sentence. Pause the video and try it before checking the answer. The completed sentence is, a horizontal line has the equation form y equals a. A vertical line is parallel to the y-axis. The line y equals 7 is parallel to the x-axis. Remember, horizontal lines have fixed y values and vertical lines have fixed x values. Now, let's find the equation of a parallel line. We need to find the equation of the line parallel to y equals 2x plus 1 that passes through the point 0, 5. Because the new line is parallel, it must have the same gradient. The gradient of y equals 2x plus 1 is 2. So our new line must also have gradient 2. The point 0, 5 tells us the y-intercept, because when x is 0, y is 5. So c equals 5. Therefore, the equation is y equals 2x plus 5. Sometimes the point you are given is not the y-intercept. In that case, follow 3 steps. First, identify the gradient from the given parallel line. Second, substitute the gradient and the coordinates of the point into y equals mx plus c. Third, solve for c. For example, if a line is parallel to y equals 3x plus 1 and passes through the point 2, 10, the gradient must be 3. Substitute x equals 2 and y equals 10 into y equals 3x plus c. That gives 10 equals 3 times 2 plus c. So 10 equals 6 plus c. Therefore, c equals 4. The equation is y equals 3x plus 4. Let's look at a critical thinking question. The statement says, the lines y equals 4 and x equals 4 are parallel to each other because they both involve the number 4. Is this true or false? Pause the video and think carefully. Remember, parallel lines are about direction and gradient, not just whether the same number appears in the equation. The statement is false. The line y equals 4 is horizontal. It goes from left to right and is parallel to the x-axis. The line x equals 4 is vertical. It goes up and down and is parallel to the y-axis. A horizontal line and a vertical line meet at a right angle. That means they are perpendicular, not parallel. The correct explanation is y equals 4 is horizontal and x equals 4 is vertical, meaning they are perpendicular at 90 degrees, not parallel. The fact that both equations contain the number 4 does not make them parallel. To decide whether lines are parallel, we need to think about their direction or compare their gradients. Let's finish with the final challenge. A rectangle has two sides on the lines y equals 5 and y equals 2. What can you tell me about the equations of the other two sides if the rectangle is aligned with the axes? Pause the video and think about the shape. The lines y equals 5 and y equals 2 are horizontal, so the other two sides must go in the vertical direction. You might have said that the other two sides must be vertical. Their equations will be in the form x equals b. The exact values of b depend on where the left and right sides of the rectangle are placed. These vertical sides have undefined gradients. The horizontal sides, y equals 5 and y equals 2, are parallel because they both have a gradient of 0. This shows how horizontal and vertical line equations can describe the sides of shapes on a coordinate grid. You should now be able to identify parallel lines by comparing gradients, recognize horizontal and vertical lines, and find equations of lines parallel to a given line. Remember, parallel lines have the same gradient. Horizontal lines have the form y equals a, and vertical lines have the form x equals b. If this lesson helped, please like the video, subscribe to Mindtier Learning, and watch the next GCSE Maths lesson to keep building your graph skills.